Good afternoon, students. In our previous session of Basics of Electrical Engineering, we talked about cells and series parallel connection of cells, right? So what is the cell basically? So a cell is a source of electrical energy, right? And it converts the chemical energy into electrical energy. So the chemical energy can be produced with chemical reaction, right? Each cell is capable of producing small amount of voltage and current, but this number of cells which are connected in series and parallel, they make a combination called battery. Okay, there are different size of cells available in the market, right? And we have been using them for long in electronic appliances. So as I said, the electric cell converts the chemical energy into electrical energy. A cell mainly has two components. One is the electrode and other is the electrolyte. Electrodes are two metal plates of different materials, and electrolyte is a solution such as acid or salt. This solution is capable of reacting chemically with both the electrodes. Okay. In that case, that EMF is developed. Okay, the magnitude of EMF, remember, the magnitude of EMF in cell depends on the nature and the material of the plates used. Okay. Also, it also depends on the nature or type of the electrolyte. And that's why we see different types of batteries with different combinations, and all of them are capable of producing more or less voltages, right? There are basically two types of cells, primary cells. These cells do not have reversible chemical action. So that means once you use them, the chemical action cannot be reversed. So we have to throw them after the usage. So they cannot store they can store the energy, but they cannot be charged again. Okay. There is another type of battery called secondary cells. There another type of cell which are called secondary cells. In secondary cells, the chemical actions are reversible. Okay, such as lead acid battery, nickel ion cell, and nickel cadmium cells. Okay, so you can recharge them, and once you recharge them, they will restore its original condition. Hopefully, in ideal condition, they are restored to their original condition. So we call them storage cells. They can store the energy for long, and then you can once again you can store the energy, and then you can charge and recharge again. Okay, fine. Just a minute. Okay, fine. Now, important terminologies related to cells. One is the electromotive force, second is the internal resistance, and third is the terminal voltage. And they are related as V is equal to E minus IR, where E is the EMF developed by the cell and V is the voltage across the terminal, low terminal. Okay, we can perform different types of grouping called series grouping, parallel grouping, and series parallel grouping. We have already seen the equations related to that, series, parallel, and series parallel. Okay, now today we will talk about the battery. Okay, we will talk about a battery. What is a battery? So when cells are connected in series or parallel or series parallel, then such a grouping of cell is called battery. Generally, a cell can deliver a small amount of current at low voltage, but if higher voltage is required, then battery cells are connected in series. And if higher current is required, then cells are connected in parallel. Okay. And if large current at high voltage is required, then a battery containing number of cells in series and further connected in parallel. So this type of connection, series parallel connection, okay, that makes a complete battery. Okay. Okay. Now we will see a lead acid battery. There are a lot of other batteries also, but this lead acid battery is very popular in a conventional application. Apart from electric vehicle, in electric vehicle we have lithium ion battery. In your mobile also we have lithium ion battery. Lithium ion batteries are also of different types. Okay, and we are not going to discuss all of them in detail, but we will only see some terminologies and basics related to that. Okay. So since the lead acid battery was very popular before a few years, so we are discussing lead acid batteries in this section. Okay, and later on you can study about lithium ion and types of lithium ion batteries in 5th semester and onwards. Okay, so this is the construction of the lead acid battery. We have a lead here. Then there is a cover. This is a cover. Okay. There is a pillar. We will talk about that later, not now. There is a container. So this one is a container. The container actually contains everything. Then we have a positive plate. I will show them later on. Then we have a negative plates also. And between positive plate and negative plates, we have a separator. Okay. You can't merge positive and plate and negative plate. Otherwise, it will result in a short circuit. Right. So these are main components, I can say. One is the container in which everything is contained. Second is the plates. Okay. Positive plate and negative plate. A separator is between the positive plate and negative plate. Electrolyte. Okay. Electrolyte solution. Battery cover. As you can see, the cover is here. Okay. Vent pipes. I will show them later. Intercell connector. I will also discuss about this, and cell terminals. Right. So a container. So you can see them here. You can see it here. It is the outer body of the battery. Okay. It is made of hard rubber or plastic material. We prefer plastic nowadays because it is durable. Okay. It is tough, right? And it cannot react directly with other chemicals. Okay. Unless there is some specific chemical, it doesn't react directly. Right. So rubber and plastic, they are preferable materials. Okay, and this container is sealed at the top, as you can see with the blue one. Okay, you can see with the blue one, this is sealed. Okay, so container is sealed at the top to prevent the spilling of the electrolyte, so that the electrolyte doesn't come out of the battery. Okay, and then at the bottom, sufficient space is left so that any sediment means जो भी कचरा होता है, whatever dust or whatever extra material is there, okay, and if there is anything that dead material that which is a result of some reaction, that everything it drops at the bottom. Okay, and it doesn't short circuit the positive and negative terminal. That is a purpose. So container is actually a very, very important component. Okay, it houses everything. Okay, Second is the plates. Okay. Generally, you are seeing both type of plates here. Okay. I have shown positive and negative both plates. Okay. So alloy of lead sheets covered with lead peroxide. They are used as electrodes. And to increase the capacity of the battery, large number of plates in each cell is used. Okay. So that means there are number of positive and negative plates like 11, 13, 15 or 17. And all of them, all those plates are connected. That means they are placed one after another or alternatively. So that means you place a positive plate, then you place a negative plate, then you place a positive plate, then you place a negative plate, then positive, and so on. So such groups are formed. Okay. So number of positive and negative plates of each cell are alternatively placed. Okay. And they are separated by an insulator called separator. That's because this is metallic, this is metallic, this is also metallic. So you need some kind of insulator in between so that they are not short circuited somehow. Okay. So that's why we need a separator. Understand? So basically we have a separate compartment, you can say, between that separator. We have a separate compartment in which you place the cell. So you can see them here. You can see it here in the first one and in the second one. Okay. The first one is a separator material. Okay. To reduce the internal resistance of the cell and save the space, the plates are placed very close to each other. Remember, this plates plus minus, they are placed very close to each other. And to prevent this short circuiting of the plates with each other, they are separated by a rubber sheet or a relevant material having large number of small holes, which is called separator. Okay. But that means it's porous one. There may be some small, very, very small holes. Okay. And we call it separator. Just a minute. I need to tell this person. Sorry, I cannot stop them. They are for safety purpose. They are actually sanitizing all the cabins. Just a minute. Okay. Another helping hand who is actually helping sanitize each and every cabin. Sorry. Fine. So electrolyte. Fine. So here you can see both plates as well as separators, right? Metal plates separated by separators. Fine. Okay. Electrolyte. We use a diluted sulfuric acid. We can't use sulfuric acid with concentrated sulfuric acid. It can be dangerous. So we use a diluted sulfuric acid. See, this is becoming very irritating. Number of students are just leaving and entering the session again and again, right? So it causes interruption in the class. So please avoid doing this. Okay, so diluted sulfuric acid is used as an electrolyte in the lead acid battery. Yeah, I can understand that. I can understand. But then you should also understand that I can't just keep on approving request again and again and again, right? Okay, so sulfuric acid is used in lead acid batteries. Sulfuric acid is added to the water in such a proportion that with a fully charged battery, the specific gravity is about 1.28 to 1.29. Okay, the specific gravity. This is very, very important, and you might have studied this in chemistry. Specific gravity of the material. So specific gravity of a fully charged battery will be 1.28 to 1.29. We will talk about this in coming slides. Okay, then we have a battery cover. Okay, so each cell has a battery cover with a molded hard rubber. Okay, hard rubber. Okay, and the joints between the cover and container are sealed with acid resistant materials so that acid doesn't directly react with the rubber. Okay, and in this battery cover, two openings are provided mainly, one for the positive and one for the negative, right? And you can see them here. Okay, another one is the vent caps. Sometimes we look at them as terminals. They are not terminals, actually, they are vent caps, right? So vent caps, these are vent caps, and you must have seen them in lead acid batteries. If you have actually seen the lead acid battery, then you might have seen this vent caps on the top. Okay, this vent cap as a hole here, right, to allow free exit of the gases, because of the chemical reaction, there may be gases, and if you don't allow gases to come out, then they will increase the pressure. I think you are well aware of the pressure and its effect, right? So there may be a pressure, and this pressure may ultimately lead to the blast. Okay, so to allow the free exit of gases formed in the cell during charging, we allow vent caps. Okay, the vent pipe can be removed for adding pure water in the cells. The vent cap is also removed to insert the nozzle of the hydrometer for checking the specific gravity of the electrolyte. Right. So in case you are using hydrometer for checking the specific gravity, at that time you have to remove this vent caps, and then you check it through the nozzle. Okay, then we have intercell connector like this. This is the intercell connector. Okay, the cells which are connected, placed in the same container. I think you have seen the containers, right, in the very beginning. So cells which are placed in the same container, they are connected in series with the lead alloy link. So this is a link you can put here, you can put it here, and this is called intercell connector. Right? This is inside the battery, inside the container. So you can't see them directly, but they are there inside the container. Okay. Then we have cell terminals. So one terminal will be negative, another terminal will be positive. Okay. And these terminals are made of lead, once again, PEB, lead. Okay. The positive terminal, normally it happens that the positive terminal is marked with red color and the negative terminal is marked with black color. Sorry. Okay. Okay. Am I audible now? Because I was interrupted. There was an interruption in the connection. Am I audible now? Okay. Fine. So if the entire body is black, then probably there will be plus carved here and minus carved here inside the container. Okay. So not every battery will have the red color terminal or a black color terminal, but in place we can have marking of plus and minus in the battery. But they are ultimately they are cell terminals, okay, which are connected to the to your car or whatever application is there. Okay, now how does it work? How does this lead acid battery work? So we have already seen it is like this. Okay, one is the lead peroxide, this one plus one, and another one is the sponge lead. Fine. So that's why this is called lead acid batteries. So there is a lead terminal and there is acid inside it, H2SO4, diluted one, right? On one hand, we have lead peroxide, other has the sponge lead, right? So how does it work then? Do you want to draw this? Or is it fine? It looks simple. Okay, then you can draw this. Because when I'm discussing, while I'm discussing, this figure might not be visible. Okay, that is also fine. I can send the PPT. I will send the PPT. Fine. Okay. So just to remember, in a container, one is plus is lead peroxide, other is the sponge lead -1. In between, there is a sulfuric acid, the diluted one. Okay. And at the end, we connect battery load to external terminals. Now let's see what happens. So the lead peroxide, PbO2, is of chocolate brown in color. Okay. And the negative plate is of spongy lead, gray in color. Okay. So we both will have different colors. Both the plates are immersed in a diluted sulfuric acid of specific gravity 1.28. Okay. When the load is connected across the terminal of the cell, it starts delivering the current to the load, and this process is called discharging of the cell. In this process, the chemical energy is converted into electrical energy. And how it happens, that is shown here. So when the load is connected, the sulfate ions move toward the cathode and hydrogen ions move towards the anode. So it is like this. Okay. Basically, it is PbO2 on one side and H2SO4 also, right? So on the cathode side, there is a spongy lead, okay, which combines with SO2, SO4, right? There are two things. Fine. So H2SO4 is split into two, H2 and 2H and SO4. So Pb at cathode, Pb combines with SO4 and it becomes PbSO4, which is lead sulfate. Okay. And on the other hand, on anode, we have lead peroxide plus H2SO4 plus 2H. Okay. Plus 2H. This 2H and PbO2 plus H2SO4, they combine together, make lead sulfate, and then releases 2H2O. This is nothing but the water. Okay. But in this process, electrons, of course, electrons are released. Okay. So electrons are released, right? So these electrons which are released, these electrons will go from here to here. This is the flow of electrons. So here electrons are received, okay, and here electrons are emitted. Fine. So that means there will be plus electrons emitted here, and here they will be combined. So ultimately you get water plus lead sulfate. Lead sulfate is actually accumulated on the plate, both the plates. Okay. Here also the lead becomes lead sulfate, and here also the lead will become lead sulfate. Fine. So during discharging, both plates are converted to lead sulfate. Specific gravity of the sulfuric acid is 1.1115. Terminal voltage will fall from 2 volt to 1.8, and chemical energy changes to electrical energy. So this process happens during the discharging. For recharging, what you have to do, for recharging, we supply, right? We provide a supply. So what happens? The lead sulfate at a particular anode, we have anode here, and then the lead sulfate combines with H2O and O to make lead peroxide again and H2SO4 again, right? Whereas at cathode, we already have lead sulfate, which combines with 2H. So this 2H here, that means H2 and SO4 here, they together combine and become H2SO4. So once again, at cathode, we will have a spongy lead, and at anode, we have a lead peroxide. We are getting it back. Okay. And of course, where does this 2H and H come from? So they come from H2O, remember, right? And what causes this? It is the flow of current which causes this. So during recharging, the plates will regain their original composition. Specific gravity of acid will become 1.28 because this H2SO4, H2SO4, both are coming back. Okay. Terminal voltage will increase from 1.8 to 2 volt, and electrical energy is converted to chemical energy once again, and it is stored in the cell. So thus we charge the cell again. Sorry, the battery again. Okay. Now, this was the internal construction about the battery. But normally we do not bother as such about the construction of the battery, because as an electrical engineer, we are more concerned about the output capacity of the battery, right? That means how much voltage it will provide, how much current it will provide. Do I need to connect them in series and parallel? Okay. So that is called capacity of a battery. How much energy it can store and how much energy it can deliver. Okay. So the quantity of electricity or the energy, you can say, or energy, which a battery can deliver during single discharge until its terminal voltage falls to 1.8 per cell, and that is called the capacity of the battery. Okay, the capacity of the battery is normally expressed in ampere hours. Remember, ampere hours. So sometimes we call it 12 volt, 40 ampere hours, or 18 volt, 20 ampere hours. If you combine them, then 18 volt into 20 ampere hour is equal to 360 volt ampere hour. This is what? Watt. Okay. That means it becomes 360 watt hour, which that means it can provide 360 watt for 1 hour. Understand? That's how we define the battery. Or you can say that 40 ampere hour. That means it can provide 40 ampere for 1 hour. Now it also means that we can provide 20 ampere for 2 hours. Both are 40. This is also 40. This is also 40. Understand? Okay. Now simple. What is the ampere hour capacity of your mobile battery? Just try to have a look. What is the ampere hour capacity of your mobile battery? Of course, your mobile battery, remember, your mobile battery is not the lead acid battery, but still it has got the capacity. So you can proudly say that my battery is 6,000 milliampere hour. 6,000 milliampere, that is 6,000 into 10 raised to minus 3 ampere hour. That means it is a 6 ampere hour battery. Now, if you use this continuously, it lasts for 12 hours, and 6 ampere hour lasts for 12 hours. So that means it is 0.5 ampere. Exactly. Okay. It is 5,000 milliampere hour. Okay. So that means your battery of mobile is actually providing 0.5 ampere current for 12 hours. Okay. Your battery is providing 0.5 ampere current for 12 hours, and that's why you call it 6 ampere hour, or you call it 6,000 milliampere hour battery. So that's how the capacity of a battery is calculated. I hope everybody has the idea of capacity of the battery, because it is actually frequently asked in many MCQs and in competitive examinations also. Okay. 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 A fully charged battery has a specific gravity of 1.28. When it is fully discharged, then it goes to 1.15, less than 1.15 when it's fully discharged. Okay. Now, you should not allow your battery to fall less than 25%. Okay? Never. In case of lead acid, okay? In case of lead acid, you should not allow the battery level to fall below 25%. Or you can say, to get a good life of the battery of lead acid, you should keep the specific gravity more than 1.18. Okay? And that will lead to more, that will lead to nearly 40%. Right? So remember, though you can say that this battery has got 100% charge capacity, you cannot fully drain the battery. Okay. Now, in your mobile, you can directly see it, right? Nowadays, we have digital controller and everything digital. So that is one thing called state of charge, which we are not discussing now, but that is called state of charge. The state of charge is actually something which is displayed. Okay. So this state of charge is displayed on your device most of the times, right? Either in terms of number or in terms of indication. For example, this 1, 2, 3, 4, like this. So it is displayed in terms of state of charge. So if your state of charge falls below certain value, you should not discharge it further. That's how you can say that whether the battery is fully charged or not. Right? The specific gravity is one of the measure of charging level of the battery. Right? If it is 100% charged, the specific gravity will be 1.28 to 1.29, which you can measure using hydrometer. Here it is 1.23 to 1.25. At 50%, it is 1.19 to 1.2, and less than 50%. If it is below 1, if it is around 1.15 to 1.16, then you can say that it is 25% charged. And if it falls below 1.13, then you can say that it is fully discharged. You should never allow your battery to get fully discharged. It is not a good practice to fully discharge a battery. Okay. Now, when we want to charge lead acid battery, right? So whenever the terminal voltage falls below 1.8 per cell, then battery is put under charging. So following things must be kept in mind, right? The battery will be like this. This is the battery. It's a negative terminal. It is a positive terminal. So you connect a source, external source, and then through a resistor. Okay. And then you start charging the battery. The current I will flow and it will go into the terminal. Now remember, whenever we are charging the battery, only DC voltage source should be applied, not an AC. Okay? AC can never charge the battery. Fine? Positive terminal of the battery is connected to the positive terminal of the source, and negative terminal of the battery is connected with the negative terminal of the source. Charging voltage of the source, if you want 1.8 volt across these two terminals, right? Then discharging voltage should be 2.5 volt. And the charging current should be 1 ampere. Okay, now that depends on the rate and the size of your battery. Okay. But normally we follow this practice. Okay. Now what type of care? Now this is all about basics of charging of the lead acid battery, right? Only apply DC voltage source, only connect plus to plus, minus to minus. Charging voltage per cell should be 12.5 volt and charging current should be only 1. Okay. And that's why when you put the charging battery under charging, then it takes long time. Okay, 1 hour, 2 hours like that. Now, we always want that our battery should run for long time. For example, if it is your two-wheeler or four-wheeler, then we want that battery should work for at least 4 to 5 years. In fact, many batteries have 3-year warranties or guarantee sometimes, right? So to get this life out of the battery of 4 or 5 years, you should take certain care and you should also do maintenance of the battery. This is applicable to your car as well as two-wheeler. Your car, scooter, or your bike. Okay. 1. The battery should not be allowed to use when the EMF falls below 1.8 volt per cell. Right? That means if there are, let's say, if there are 8 cells, right? Then let's say there are 8 cells, then the voltage should not fall below 14.4. Understand? If there are 5 cells, the voltage should not fall below 1.8. The specific gravity of the acid should always be more than 1.15. Okay? So don't always keep on adding water, right? Don't keep on adding water every time. Okay? Right? Third, battery should never be left in the discharging condition for a long time. Otherwise, if your battery is discharged and you keep it there for a long time, then after some time it will become useless, totally useless. Okay. Fourth, when we are not using the battery, particularly lead acid battery, then the battery must be fully charged. Remember. Okay, this is applicable to your car as well as scooter. Okay, if it is discharged and you just leave it for 10, 15, 20 days, and after 20 days, you try to apply the ignition, you try to start your scooter, it will not start. Okay, so when it is not in use, then battery must be fully charged. The level of electrolyte must be checked regularly. That's what we call checking of the battery. Okay, for that, we simply ask the technician to check the electrolyte and they will say that, okay, we have added water. Fine. Okay, when the level of electrolyte decreases, then only distilled water is added. Okay, not a regular water. We should add distilled water. And the last, the battery should be charged or discharged at low rate and the temperature should not rise above 45 degrees. Remember, just to charge the battery faster, don't connect your lead acid battery to high ampere current. Okay, it may lead to disaster. And this happens with, this can happen with any battery. Okay, the charging rate must be controlled very, very carefully in case of battery. Okay, you can't simply connect your battery to any amount of voltage, any amount of current. We should be very, very careful. Otherwise, there are chances of explosion in the battery, because batteries, especially the lithium ion battery in our mobile, is very sensitive to the level of charge. And because the chemical is involved, so we should not allow the temperature to rise above 45 degrees. Okay, precautions. While working with the battery, we should take some precautions. One, the battery terminals should not be short-circuited. Remember, never short-circuit battery terminals. Okay, it could be dangerous. That means if the battery is like this is plus, this is minus, never try to short-circuit it. It could be dangerous. Second, keep your battery terminals clean. So many times you see that some dust and many things are accumulated on the surface of your terminal. Okay, then we should get it clean. Don't try to clean it on your own, but we should get it clean at regular interval. Whenever we are charging, the polarity must be checked very, very carefully. That means if you are charging, always ensure that plus is connected to plus, minus is connected to minus. Never do a reverse. Otherwise, the battery will be discharged to a very, very low level. Keep your battery in a well-ventilated room. In case you are using the battery for storage purpose, for example, in your solar system, okay, let's say you are using battery for your UPS inverter, you are using a battery, then you should always keep it in a well-ventilated room. Otherwise, those gases which may be developed. Those gases can be dangerous for human. Okay, and always keep flames away from the ventilation of the battery, right? Because this is an acid battery, lead acid battery. If it catches fire, it could be dangerous. What are the applications of the battery? One, we are using it for automobile, for starting and lighting. Okay, a very well known. For lighting of railway trains, in railway trains also. Yes. Wait, Arnold, I not ask anybody to enter enrollment number now. I will finish it and then I will ask all of you to enter enrollment. Okay. It is used at substation to operate some protective devices. Okay. So whenever in future you visit the substation or generating station in electrical engineering, then in substation you will find these batteries to operate protective devices. It is used in telephone exchanges, but this is all these things are obsolete nowadays, so you will not see them. Used in emergency tube lights. Yeah, so sometimes we have those emergency lights. Okay, so for emergency lights we use this lead acid batteries. Okay, and in fact, if you see street vendors around you, those street vendors are actually using lead acid battery for lighting purpose, for LED lighting purposes. Okay, and it can also be used in remote rural areas for lighting purposes. Nowadays LEDs are available, so you can simply connect those LED lamps to lead acid battery and they will work fine. Okay, that's it for today. You can enter your enrollment number now.